Deployment and Scalability, Microsoft SharePoint Server 2010, Module 2, Topologies. At the end of this module, you'll be able to list Microsoft SharePoint Server 2010 topologies and describe the search components in SharePoint Server 2010. SharePoint Server 2010 topologies can vary from a single server farm, where the web server, application server, and database server all run on a single system, to a three-tier topology where the web server, application server, and database server each run on separate systems. The topologies can scale out even further, placing one or more query components and crawl components on separate servers and/or by adding additional web servers, application servers, and database servers. The services on the server page in Central Administration site list services that are started or stopped on specific servers in the farm. Some of these services are associated with service applications. You can deploy service applications by starting the associated service on desired server computers. Some of these services are not associated with service applications. The SharePoint Server Search service is used for query, crawl, and admin components. This service controls the search service application pages in Central Administration, where query and crawl components are deployed to the servers. The Search Query and Site Settings service, seen on the Services on Server page, is used for configuring one or more search query processes. This module will examine the components that are part of the search in the SharePoint Server 2010. Note that search components for the query and crawl components are deployed to servers using the search service application pages in Central Administration and not the Services on Server page. In SharePoint Server 2010, the number of services and corresponding databases is greater than on previous releases. The recommendation for scaling out a farm is to group services or databases with similar performance characteristics onto dedicated servers and then scale out the servers as a group. For example, group all client-related services onto one or two servers and then add services to this group as needed to satisfy the user demand for these services. In some cases, you might need to create a dedicated server group for a single service, such as an Excel calculation service or search. The suggested service topologies covered in this module group service applications and the related components, for example databases, into several different logical groupings that can be used as a starting point. In large environments, the specific groups that evolve for a farm depends on the specific demands for each service. Note that server groups is a planning concept. This is a term and a concept which is not found in Central Administration. The web server hosts web pages, web services, and web parts that are necessary to process requests serviced by the farm. It also directs requests to appropriate application servers. The search proxy is the SSA proxy that installs on any farm that consumes search from this SSA. It runs in the context of the web applications that are associated with the SSA. The web server is necessary for farms that include other SharePoint Server 2010 capabilities. In dedicated search service farms, a web server is not necessary because the web servers at remote farms contact application servers directly. In small farms, a single system can act as a web server and the application server. The following services can also be running on a web server: Microsoft SharePoint Foundation incoming email, Microsoft SharePoint Foundation web application, Microsoft SharePoint Foundation user code service, and the Windows SharePoint Services workflow timer service. Application servers are associated with services that can be deployed to a physical computer. Each service represents a separate application service that can potentially reside on a dedicated application server. Services with similar usage and performance characteristics can be grouped on a server and scaled out onto multiple servers together. For example, client-related services can be combined into a service group. After deployment, look for services that consume a disproportionate amount of resources. Consider placing these services on dedicated hardware. In a small farm environment, all databases can be deployed to a single server. In larger environments, group databases by function, for example search, and deploy these to multiple database servers. Search-related databases should be installed on their own dedicated database server, and depending upon the size of your search deployment, you could have a crawler database on dedicated database server. This will be discussed in more detail later on in this module and also in modules 5 and 6. Search in Microsoft SharePoint Server 2010 is re-architected with new components to create greater redundancy within a single farm and to allow for scalability in multiple directions. Each of the components that make up the query architecture and the crawling architecture can be scaled out separately based on the needs of an organization. The query architecture includes a query processors, query components, index partitions which reside on application servers running the query component, and property databases which can be hosted on dedicated database servers. An index partition is a portion of the entire index. The index is the aggregation of all index partitions. Typically, the index partitions are spread across multiple application servers running the query components. For example, a farm with 3 application servers running the query component will likely be configured with 3 different index partitions that represent 1/3 of the index in each. Deploying index partitions across multiple application servers creates a faster query architecture because the processing power of multiple application servers is used to respond to the queries. Index partitions include one or more query components. Multiple query components mirrors for a given index partition can be deployed across multiple application servers to achieve redundancy. Typically, 2 query components are configured for each index partition, and these query components reside on different application servers to achieve redundancy of the index partition. The crawl architecture includes several components that can be scaled out based upon crawl volume and performance requirements. The crawl component. Multiple crawl components can be deployed to crawl simultaneously. Each crawler is associated with a crawl database. Crawlers reside on application servers, and crawlers index content and propagate the data to the index partitions controlled by the query components running on the application servers. The crawl database manages crawl operations and stores crawl history. You can assign multiple crawlers to each crawl database for redundancy. In this case, each crawler will crawl different content during each crawl cycle. The property database, also considered as part of the crawl architecture, stores properties for crawl data. The number of property databases depends upon the volume of the content that is crawled and the amount of metadata that is associated with the content. SharePoint 2010 includes an updated services architecture that enables farms to connect to multiple farms to consume cross-farm services. In large environments, consider deploying one or more of the following options. The Enterprise Services Farm, a farm that hosts the most commonly used cross-farm services including search, and a dedicated search farm, a farm that is optimized for search only. The web server hosts search web parts and web part pages for answering search queries. The search proxy is the SSA proxy that installs on any farm that consumes search from this SSA. It runs in the context of web applications that are associated with the search proxy. The search query and site setting service, also known as the query processor or QP, receives the query from the SSA proxy connection, which then sends a query to one active query component for each partition, and or to the property database depending upon the nature of the query. If you have a web server and the query system on the same physical server, the search proxy and QP will both be on the same server. If you have a farm where your query component is on its own application server, the search proxy and the QP will not be on the same server. The search proxy will be on the web server, and the query processor QP will be on the application server running the query component. If you have a parent-child farms where you are consuming search from different farm, for example a dedicated search farm, you do not need to have a web server on the farm, because the web services in your parent farm will contact the query system directly. The search proxy will still be present on the parent farm web servers, handling the search requests from web applications. The queries are sent to the query processor in the child farm, for example a dedicated service farm, for example a dedicated search farm. The query processor is no longer on the parent farm web servers. It resides on the child farm, such as the dedicated search farm, and application servers running the query component. In small farms, a single system can act as a web server and an application server at the same time. In this slide, we'll go through the search query system. The search proxy. This is the SSA proxy that installs on any farm that consumes search from this SSA. It runs in the context of web applications that are associated with an SSA proxy. The search query and site setting service, this is also known as the query processor, receives the query from the SSA proxy connection. A query processor sends the query to one active query component for each partition and or the property database depending upon the query, retrieves best bets and removes duplicates to get the search result set, security trims the results based upon security descriptors in the search administration database, retrieves the final results, sets metadata from the property database, and finally sends the queries back to the proxy. The index partition. This is the logical group of query components representing a subset of the full text index. The sum of index partitions comprises the full text index. However, note that the query components contain the actual subset of the index. An index partition is associated with one property database at a time. The search query component. This is a query component that contains all or part of the full text index. When queried by the query processor, the query component determines the best results from its index and returns those items. A query component can be created as active, which means it will respond to queries by default. Adding multiple active query components for the same index partition will increase throughput. Or failover, which means that it will only respond to queries if all active components for the same index partition have failed. The search administration database. Created at the same time as the SSA. The search administration database contains the SSA-wide data used for queries like best bets and security descriptors, as well as application settings used for administration. The property database. A property database contains the metadata, title, author, and related fields for the items in the index. The property database is used for property-based queries as well as retrieving metadata needed for display of the final results. If multiple index partitions exist, the index partitions can be mapped to different property databases. Application server running the query component. Serves queries results to web servers. Holds either the entire index or one or more partitions of the index as configured by the administrator, runs the query processor. The query processor forwards query requests to the index partitions, to one query component for each index partition, and then merges the results to display to the users. The query processor is also responsible for security trimming, duplicate results detection, and gathering and displaying properties. The query processor is not illustrated in this model because you cannot configure the query processor. At least one server in the farm must host the query component. Two or more application servers provide redundancy based on the configuration of the index partitions and query components. Adding application servers may increase performance. And finally, the query component can be shared on a server with a web server, with other application server applications and services. In this slide, we'll examine the search crawl system. The administration component. This is an administration component that is used when starting a crawl, as well as when performing administrative tasks on the crawl system. Crawl component. A crawl component processes crawls of content sources, propagates the results to the index, and adds information about the location and crawl schedule of content sources to its associated crawl database. Search Administration Database. Created at the same time as the SSA, the Search Administration Database stores the security descriptors discovered during the crawl, as well as application settings used for administration. The crawl database. A crawl database contains data related to the location of content sources, crawl schedules, and other information specific to crawl operations. They can be dedicated to specific hosts by creating host distribution rules. A crawl database only stores data. The crawl components associated with the given crawl database do the crawling. And then finally, the search query system, which is discussed in the previous slide. The application server running the crawl component runs one or more crawl components, typically hosts the search administration component. At least one server in the farm must host the crawler component. Two or more crawler components provide redundancy based upon how crawlers are associated with the crawl database. You can add more crawler components to increase performance and to scale for capacity. And finally, this component can be placed on the same system running the web server or with other application servers. The database server hosts search-related databases. It can also host other SharePoint 2010 databases. It can be mirrored and clustered. And to increase performance and capacity, consider adding disks to the database server or adding database servers, depending upon if you encounter a bottleneck. Limited deployments of Microsoft SharePoint Server 2010 are typically used in evaluation environments and production environments for a limited number of users. A single server farm is typically used for evaluation purposes where the total number of users using the system is less than 100 users. A two-tier farm can be used with up to 10,000 users, depending upon the demands of the working environment. If high availability is required, more than 1,000 users, two clustered or mirror database servers are recommended. Small farm architectures serve a large number of users and scale out based upon how heavily services are used. Due to the greater number of services, including client web applications, more requests per user are expected in the new version compared with the old versions of SharePoint. In a two-tier small farm, two web servers can serve between 10,000 and 20,000 users. All of the SharePoint databases are on their own dedicated service, as shown here. A three-tier small farm is essentially the same as a two-tier small farm, except that the third tier has been added, the application server tier. A dedicated application server has been added for environments with moderate service usage. The third example of a small farm topology, a three-tier small farm, building on two previous examples, is optimized for search and uses hardware dedicated to search databases. This topology, being optimized for search, will work well in environments with up to 10 million searchable items. The medium server farm illustrated here is scaled for search to serve approximately 40 million items. Beyond this search scale, the recommendation is to deploy dedicated search farm. Scale out all other services based on utilization of other services within the farm and the volume of content of the farm will host. The number of users will affect the requirement for the number of web servers. Factor 10,000 users per web server as a starting point. Adjust the number based on how heavily the servers are utilized. Heavy use of client services will increase the load on web servers. Based on utilization, consider either adding additional servers with all the non-search components installed, or add additional servers to dedicated resources to specific services. For example, if performance data indicates that Excel services is using a disproportionate amount of resources, offload this service to a dedicated server. Add additional database servers based upon the volume of content in your environment and sizing targets for your organization. You should always keep search databases on dedicated database servers. The recommendation for scaling out a large farm is to group services or database with similar performance characteristics onto dedicated servers, and then scale out the servers as a group. The topology shown here illustrates a practical example of this concept. In this module, you have learned to list Microsoft SharePoint Server 2010 topologies and describe the search components of SharePoint Server 2010.